Hi guys, it's Yoshi. You might be wondering what happened to my voice. This is actually my real voice. Only the true fans who watched the sub, not the dub, would know. You might also be wondering how I am able to talk without moving my mouth. The truth is that I am actually not talking right now. I am communicating directly to your soul through my telepathic skills that I learned from Lord Kirby. You might be thinking I just contradicted myself, but please don't mind that. I think it is best not to overanalyze things. You might also be wondering why I decided to become a math teacher. It's actually surprisingly simple. I'm not making enough money from babysitting and racing and playing tennis and being a part-time horse and evading taxes. If you have a question during the lecture, feel free to shout it out, but please don't get mad at me if I don't hear you because I don't have ears. But enough small talk. Let us commence. What is the derivative of a function? The derivative of a function is the slope of the function. The derivative itself is another function. Let's take a look at an example. F of x equals 2x. I'm assuming you know how to find the slope of a line. For straight line graphs like this, the slope everywhere on the line is the same. In this case it's 2. So the derivative of this graph is just 2. Many people write the derivative as f prime of x. Another way people write it is as dy dx. Don't let that confuse you. They mean the same thing. For the purposes of this lecture, I'll just stick with f prime of x. Notice that the derivative doesn't have x anywhere in it. That means the derivative is the same everywhere regardless of x. In this case the derivative is always 2. In other words, the slope at all points on the graph is the same. But for most functions, this will not be the case. Here is another example. F of x equals x squared. Clearly, the slope in this graph is not constant. It keeps changing. So how are we going to find the derivative? Let's start with our understanding of slope. Slope is rise over run, or in other words, the change in y over change in x. Let's say we want to find the slope at some arbitrary point x. Since it's easy to find the slope of a line, let's draw a line that goes through x with a slope that has approximately the same slope as the graph at that point. This secant line intersects the graph at 2 points. The first point is x, f of x, and the second point is x plus h, f of x plus h. It doesn't really matter what x you choose. Now we use the slope formula to get this expression, f of x plus h minus f of x over x plus h minus x, which is an approximation of the slope at x. But how do we make it more accurate? It's actually surprisingly simple. As h gets smaller and smaller and approaches 0, the 2 points will keep getting closer and closer until they are basically at the same point and the slope is exact.
Nice.
Now the line is called a tangent line, meaning it's just touching the graph at basically 1 point and has the exact same slope as the slope of that point on the graph. So to do that we'll use a limit. We can express the derivative of f of x as the limit as h approaches 0 of f of x plus h minus f of x over h. Now you can plug in any x value to this expression and you will get the numerical answer for the slope at that point. That's basically it for understanding the concept of a derivative. Now let's find the derivative of f of x equals x squared by plugging it into that expression. Take some time to verify this algebra for yourself. Let's verify that this makes sense. Here is the graph of x squared together with the graph of its derivative, 2x. When x is negative, the derivative is negative, meaning that the function should be decreasing, and this is indeed true. When x is positive, the derivative is positive, meaning that the function should be increasing, and this is also true. When x is 0, the derivative is 0, meaning that the slope of the function when x equals 0 is 0, and that's true. Another important concept is that the derivative itself is a function, so you can take the derivative of a derivative to get the second derivative, which measures the concavity, or in other words the change in the slope with respect to x. Okay, now I want you to try a problem by yourself. Find the derivative of f of x equals x cubed. Pause the video and try it.
Time!
Here's the answer. You basically just do the same thing. Alright, that's it for now. Thanks for watching, and next time I'll talk about more stuff and examples and techniques to do these faster maybe.